So this first one says we want to know for what values of p is this going to converge. So we're going to take this exponent, this 2p, and we want for that to be bigger than 1. And so dividing by 2, p is going to have to be bigger than a half. So that one is C. And I know that was written as an integral instead of a series, but remember the integral test says whatever the integral does, the series is going to do as well. So if the integral converges, or if the series converges, then the integral is going to converge as well. All right, for this one, this I think is arguably the weirdest question on here. For which values of p would this converge? I would honestly just test some numbers and see what works. If you pick something between 0 and 1, so let me write this out. If p is between 0 and 1 or equal to 1, when you do the limit as n goes to infinity for that, if p is a fraction, say it's like a half, you would have n to the first over n to the 1/2. So the numerator is bigger than the denominator and it would go to infinity. Or if p is 1, you'd have n over n, it would be a tie, you would use the coefficients, and so it would go to 1. So it would either go to infinity or 1, but in either case, it's not 0, and so it diverges by the nth term test. So remember, if that comes out to anything other than 0, then it's going to diverge. So it can't be A and it can't be B. So out of what's left, it's either going to be bigger than 1, bigger than or equal to 2, or just bigger than 2. And so what I would do is I would just test 2. Now, if you do the limit to infinity, that is going to be 0. So it might converge or it might diverge. Remember, if this equals 0, we don't get to make a conclusion. So I'm going to do the integral test and have p be 2 and just see what this will come out to. Oops, let me make it x instead of n here. So we're going to see what this integral does, and if it converges, then great, and if not, then great too. Either way, we'll be able to answer the question. So we're going to do a u substitution. U is going to be the x squared plus 1. Du is 2x dx, and we'll adjust with a 1/2. So it's going to be 1/2 integral of 1 over u du. And so that antiderivative is going to be ln. So this will be 1/2 ln of x squared plus 1. And we're going to evaluate from 1 to b. So this is going to be upper boundary minus lower boundary. So that would be 1/2 ln b squared plus 1 minus 1/2 ln of 2. And then lastly, we're going to evaluate the limit to infinity. So as b goes to infinity, this is going to go to infinity. Again, ln is going to head upwards forever. And so this integral diverges. And so that means if p is 2, the series is also going to diverge. So it can't be bigger than 1 if 2 won't work. And it can't be equal to 2 if 2 won't work. So it's going to have to be bigger than 2. So E is our answer choice for that. I think that was arguably the hardest one on here. And honestly, I would have just tested them to see what would have worked. All right, so this is really like 3 problems in one. So you're checking for convergence or divergence, and it's which of the following diverge. So this first one, if you want to put like a 1 in here, this is like 1 times r to the n. This is geometric. And r is this sine of 2 over pi. So if r, the absolute value of r, is less than 1, then it's going to converge. And this will be less than 1. Sine waves between -1 and +1. So it's gonna stay between -1 and 1. It's gonna be a really little number, like a half or a third or a fourth. And pi is 3.14. So you're gonna have like half over 3. It's gonna end up being smaller than 1. The absolute value of it will be smaller than 1. So that converges. This one is a p series, and p is 1/3. Now, geometric and p-series have the opposite rule. For geometric, if r is smaller than 1, it's going to converge. For p-series, if p is bigger than 1, it's going to converge. So this p-value is smaller than 1, and so that one diverges. And then this one, I'm going to do the nth term test. So limit as n goes to infinity of this. And again, this is like who's in charge here. You have e to the n in the numerator and e to the n in the denominator. So since that's a tie, we're going to use the coefficients, 1 over 1. That's going to go to 1. And if it comes out to anything other than 0, then it diverges. So which of the following series diverge? Well, we got 2 and 3, and so that one is D. But this is tough when it's all of the information jumbled up together like that. Like you're not doing all questions on P series or all questions that are geometric series. So, you know, it's tough. I think the next one was kind of like that too. Yeah. So which of the following series converge? So this first one is a P series, and P is a half, and a half is smaller than 1, so it diverges. And then for this next one, it's 1 over n to the 5th. So that's a P series as well, where P is 5, and so P is bigger than 1, so that converges. And then this one is geometric. Again, this would be like 1 times r to the n. It's a times r to the n. So this is geometric, and r is e over pi. So e is about 2.7, pi is 3.14, so that is going to be smaller than 1, and so that converges. So which of the following series converge? So we got 2 and 3, and so that one is E. And then for number 5, we have 2 different series here. For what values of P will both series converge? All right, so this one is a P series, and so this 2P is going to have to be bigger than 1. And so P is going to have to be bigger than a half. That's actually the exact same thing that we looked at in question 1. And then this one is geometric. The R part of it is P over 2. So for geometric, that's going to need to stay smaller than 1. So that P over 2 is going to have to be smaller than 1. And so multiplying over the 2, P has to be smaller than 2. So we want to be bigger than a half and smaller than 2. And so that one is going to be C.